About every 6 days, ghostly images of most areas on Earth emerge from the European Space Agency's Sentinel-1 program. The technology capturing these images, synthetic-aperture radar, also known as SAR, is booming. In the coming years, it may reveal tiny changes on every patch of Earth daily. Optical imagery satellites, like the U.S. Geological Survey's Landsat, use reflected light to passively take photos from high in the sky. Sentinel-1 takes its snapshots actively by using radars. Unlike optical technology, which produces the best images on sunny days, SAR penetrates clouds and works at night. An antenna on board the satellite emits microwave pulses to the surface of the Earth and records the echoes that bounce back. The more signals it gathers, the higher the resolution of the image. The synthetic aperture of SAR satellites describes an important advance. Instead of building an extremely large antenna to capture returning waves, these satellites combine signals from a relatively small antenna moving through space to sharpen resolution. By comparing measurements from different positions, SAR data can reveal topography. Images are often colorized to highlight important features, such as flooded regions. What started as a tool for military surveillance is now essential to Earth scientists examining changes in landscape over time. Comparing SAR images from the same vantage point at different times can reveal surface movements, from meters to millimeters. This technique is known as Interferometric SAR, or InSAR. One of the first applications emerged in 1989, when researchers observed the subtle swelling of fields in California's Imperial Valley after crops were irrigated. In 1993, a groundbreaking study used InSAR to reveal how the ground shifted after a powerful earthquake rippled through Landers, California. Colors on the map show meters of movement concentrated along the faults. The technique also revealed changes in the land miles away from the earthquake's epicenter. 2 years later, glaciologists used InSAR to measure the flow of ice streams in Greenland, which accelerated as the planet warmed. More recently, geophysicists were able to detect signs of deformation at several volcanoes in the East African Rift Zone, some of which were thought to be inactive. The Korbedi volcano near the city of Awassa, Ethiopia, has been inflating by almost 7 centimeters a year. The launch of twin Sentinel-1 satellites in 2014 and 2016 provided researchers with regular, freely available data. Norway used Sentinel-1 data to create a deformation map of the entire country in order to identify rockslide hazards. Inadvertently, they discovered that parts of the train station in Oslo were sinking. Private companies are also investing in SAR technology. InSAR, a Finnish space startup, plans to launch 8 or more satellites in 2021, adding to its growing fleet already in orbit. Ultimately, they hope to capture snapshots of most places on Earth several times per day, and produce images with 50 centimeter or higher resolution. Researchers envision close to real-time SAR observations to change the way we live. It could provide crucial information on natural disasters, such as floods. Quickly identifying the most inundated areas can guide response efforts. The applications are just beginning to be conceived.